Lewis here of Embedded Computing Design, and we're at Embedded World Day 1, and I'm here at the Maxim Integrated booth in Hall 3A, and I'm here with Scott Jones, who is the Managing Director of Embedded Security at Maxim Integrated. How you doing, Scott?
Great, Brandon. I'm glad you're here.
Thanks. They've got a really intriguing new product out, and it's part of their chip DNA line of physically unclonable function, or PUFs. What can you tell us about this new part?
Yeah, so this new product is our first device to integrate this chip DNA, physically unclonable function. It's a secure authenticator product within our class of devices. So great product for applications that require authentication of some product, or maybe even authentication and being able to trust data that a product is producing.
So in terms of encryption, what types of encryption are supported by this particular part?
Yeah, I mean, in terms of cryptography, I mean, the technology itself is excellent, or certainly is applicable to symmetric-based crypto, AES, SHA-type algorithms, and also certain classes of asymmetric, for example, ECC or ECDSA type technologies.
Very good stuff, and it's really hard to showcase security technologies in action, but Maxim's figured out a way to do it. You got a little demo here. Do you want to walk us through it?
Yeah, for sure. So if I click over to the demo itself, well, let me start real quick. So at a high level, we've got this sensor endpoint that I'm holding in my hand here. It's going to produce data that a web server will then utilize for the game itself, which is the demo. So if I click over to it, we've got this nice little demo that represents, in this case here, a shock sensor that's being used to make sure that goods that are being transported aren't damaged. If I start the demo, what happens is we first authenticate this endpoint, so we're reading some information out of our part, such as public keys and certificates, verifying that that's all good. If it is, we're ready to go, and so now I've started the game, and I've got an accelerometer. I could kind of measure my movement of my wrist. Oh my gosh, I hit a pothole. That's one shock event. That wasn't good. I hit another one, another shock event. And what's going on, you can see some transactions here that are recording the shock events themselves and actually providing data back to a controller so you can trust that information. So we're signing it from our product. We also have a decrement-only counter in this device. So as shock events occur, we can decrement the counter and kind of limit the number of times that it can experience that sort of an event.
Right, that's really, really cool. And hats off to you guys for figuring out a way to actually show security. I know it's not easy, but let's take a look down here and let's look at all of the different transactions that were happening here.
Yeah, for sure. That's pretty important. We started, as I said, reading out some information from the part, including public key and certificate. And then we're doing a verification on that certificate on the host controller side, which in this case is a web server. We're gonna emulating a lot of this, obviously. And then as we hit those potholes, we're getting a sensor measurement from our endpoint here, and we're signing that, again, with ECDSA. That's all going on here. We're decrementing the counter value itself, and then reading that decremented count value out that's again signed by ECDSA. And so that's kind of fundamentally what's going on. So just play the game, we hit some potholes, we decrement the counter until we've hit 3 potholes and then it's over. Or maybe you're good enough to win the game.
If you're going to be at Embedded World, why don't you stop by Hall 3A, booth 229, I believe it is, and visit Maxim and try and take a whirl at the game yourself.